Hi, my name is Stephanie Burr. I'm the education manager at the Branch Museum of Architecture and Design. I am not in the museum right now, and that is because I am, like many of you, practicing social distancing. So I am in my dining room in my home, but I wanted to show you all a really cool activity that you could do with your family while you're at home as well. And I've got my son here, Marshall. Marshall, do you want to say hi?
Hi.
And so we're going to show you, again, a fun design engineering activity that you can do called the Marshmallow Toothpick Engineering Challenge. So there are a few things that you're going to need for this activity. You're going to need a bag of mini marshmallows like these. I'll give you some tips on what to do with these, some substitutes here in just a moment. You're going to need a box of toothpicks, and paper and pencil, which we don't have here on the table, but we will get that momentarily. Before we dive right into this activity, I wanted to point out that this is an engineering challenge, and at the Branch Museum, engineers are very important people to us because of the type of work that they do. So, Marcia, let me ask you this question while you're building. Do you know what an engineer is?
No.
No? Have you heard the word before?
Yeah.
You've heard the word engineer before?
Yeah.
What do you think they do? Yeah, so an engineer is kind of somebody who solves problems. There's somebody who, they start with a problem, they figure out either how to solve it or how to improve on something that already exists. And they do that by designing something or by building something to make people's lives better. Does that make sense?
Yeah.
Yeah? Okay. So what we're going to be doing is we're going to be building a structure. Okay, and that's something that engineers are involved in too. So our challenge today is to build the tallest freestanding structure you can build with only 25 marshmallows and 30 toothpicks. Does that sound like a challenge? Yeah, it's going to be a challenge. So the first thing that you want to do before you actually start the challenge is become familiar with your building materials, as any good engineer or architect or designer would do. So again, we're going to be using marshmallows and toothpicks. You could substitute these materials with other things. So instead of marshmallows, you could use gumdrops. You could use gummies that have been, if you have like gummy worms, you could cut them up. You could even possibly use Play-Doh or clay, although that might be a little bit too soft, but you could try it out. Instead of toothpicks, you could use dry pasta. You could use pretzel sticks. Anything that has a little bit of rigidity to it could work. Kebab skewers could also work as well, as long as you cut them up so they're relatively small, about the size of a toothpick. I would also recommend if you're using marshmallows, letting them get a little stale. The crustiness of them makes them a better building material. They're not so good for eating, so definitely save some of them. Because Marshall, when I bought these marshmallows, what did you want to do almost immediately? Yeah, you wanted to eat them, right? So save some for a snack. You don't want to eat the crusty ones, but you do want to eat the bad ones. Okay, so you've got your materials. You want to start off by practicing with building with them. And the easiest thing to do is to start with two-dimensional figures and then move on to three-dimensional figures. And that's kind of what Marshall's doing right now. We did a little bit of that off camera. He's continuing to do that now. And there are lots of different things that you can do to build first two-dimensionally. And they can kind of build off of lots of different skills too, no pun intended. So you can, for example, build shapes or make shapes using the toothpicks and marshmallows. So what we did is we started off by making shapes like squares or pentagons. So you can make those flat shapes. It's a really good reinforcement of basic geometry principles. And it also, gives you a sense of which shapes may stand the best on their own, especially once you start getting into the three-dimensional shapes. You can also, while you're still thinking two-dimensionally, make some letters. We made an A. We made an M for Marshall. Okay. Since both of us, Stephanie and Marshall, have really long names, we didn't bother making our whole name, but you can certainly do that. Then you want to move on to three-dimensional shapes, because again, this is where you're really going to start thinking about what types of shapes will help you build this tall structure. So we made a couple. We made a cube. That's this six-sided cube right here. We made a tetrahedron, not a pyramid, right here. Did you make a pyramid? Okay, so this is kind of like a pyramid right here. All right, so we've got this, okay. And then you can actually start putting some of these shapes together too to see what they work like together and how stable they might be. So Marshall, in his imagination, has been making lots of different shapes. He has made, for example, a house. So you can play around with this a little bit. But Buddy, what did you notice when you built your house? What's it doing?
Tilting.
Yeah, it's kind of tilting, right?
Yeah.
So if you want to build a really tall structure, do you want it to do that?
No.
No, you don't. So that's a problem, right? We're going to have to figure out a way to keep it from doing that, right?
Yeah.
Yeah, we're going to have to think about how we want to keep it from doing that. So we'll have to think of some ways to fix that design so we can make a nice, tall structure. So now that we know some of the shapes that we can make with the marshmallows and the toothpicks, and now that we have an idea of how strong or stable some of the shapes might be, a cube, watch this, bud. All right, cube, is this really strong?
Yeah.
Is it?
No.
Not really. Yeah, I mean, it's kind of,
Yeah.
how would you describe this shape? If I put my finger on it, put your finger on it, on the top. How would you describe it?
That's really wiggly.
It's really wiggly, right? So if we wanted to build on top of it, what do you think it's going to do?
Fall.
It's probably going to fall, right?
But if
All
it falls, at least it won't break.
That's true. That's true. Probably won't break. But if we want to build the tallest structure, do you think we want to build it like that? I don't know. Okay. Well, what about well, keep it like that for a minute. What about like these? Like you built this nice kind of triangular structure here, and then this one. Put your finger on these. Is that wiggly?
No.
What about this one?
A little bit.
Is this one as wiggly as the cube?
No.
Okay, that one's not. Is this one wiggly?
No.
No. Okay.
No.
So you notice that this one is very wiggly. This one's not really. This one's not at all. And there's actually there's an engineering principle in here as to why a structure like this might be super wiggly, this a little bit, and this not so much. And we can talk a little bit about that. But it's good to kind of think those design aspects and those design failures through before you start planning your design. Speaking of which, let's actually start planning our design. So this is where you're going to want to get your paper and pencil and start sketching what you want your design to be. Okay, so we're going to start sketching our design. So again, we've got to build the tallest structure you can with only 25 marshmallows and 30 toothpicks. So what do you think it should look like? You don't know. Okay. Also, you might have noticed Marshall's wearing a hat now. He decided to put on a hat between takes. Well, what did we decide about what was the most stable shape? Okay, so triangles. Well, if we wanted to build something tall that's going to stand by itself, can we just use triangles? No. Okay. So we want to use cubes. Okay. So could we stack cubes? Like stack cubes on top of each other?
I'm gonna use this.
Okay. So how would you do that?
So I basically do this and copy it.
Okay.
And
Copy
then
it.
at the end, I'm gonna put this on top.
Okay.
But
Okay.
we have to make sure it won't wobble.
Okay. Can you draw that? Okay, so here's what Marshall sketched. He drew a structure that was 3 cubes tall and has like a little roof on top. It's got a little triangle on top. So we'll see if, what are you adding there? Oh, 4 cubes, okay.
I'm gonna keep adding them.
Okay. Well, remember we only have 25 toothpicks, right? Or 25 marshmallows and 30 toothpicks. So we might not have enough to do 5 cubes. We'll have to see. But this is what his design is going to be. So we'll have to see. Remember, those cubes might not be stable enough to do 5 stacked on top of each other. So we'll have to see what happens. Okay? Are you ready to build?
Yes.
Okay. All right. Okay. So we've got 25 marshmallows, 30 toothpicks. We're going to build our structure. We're going to see.
24 and 20.
Well, okay, so you've got what you've got in your hand. But we're going to see if we can make this structure. And as we build, what a good engineer does is, as they build, if their design's not working, they go through the process of redesign and see if they can fix it and try to, again, add things or revise it. To see if they can make it better. So, you ready to build?
Yeah.
Looks like you already started. Okay, let's do this.
Let's see, you can start.
Okay. So, are you building the first cube?
Yeah.
All right, I'll build the second cube. So, as we build, there are a few things to keep in mind for this challenge. And we're taking it as a given. But some special rules, again, you have only 25 marshmallows and 30 toothpicks. And you get what you get, and you don't throw a fit. So if you accidentally break a toothpick or eat a marshmallow, you lose that building piece. You lose that material. So you have to be very careful. You can't use tape to hold up your structure, or glue, or anything else. Okay, you're just limited to your supplies here. And of course, at the discretion of the parent or the teacher or whomever, you could do a time limit, which might make it even more fun. We're not going to do that here because we don't want any added stress. And plus, we're just showing you how to build this. All right, so we've already got 1 cube, right?
Yeah.
Yeah, you're a fast builder.
I know.
And so humble. All right, here, if you can stick the toothpicks in.
I'm actually about to have 2 cubes.
Well, I know, because I can add the second layer on.
Actually, no, 3.
Whoa.
Do you know how?
Huh.
All I have to do is stick this, and then stick that one on.
Oh, you want to use that?
Yeah.
Yeah, we can use that for the sake of time. Right.
Let's see if this will stay. It falls over.
Yeah, we already noticed that it's starting to lean some, right? That's kind of a problem, isn't it?
Yeah.
Okay. Is it going to stay up? Oh no. Oh no. Okay. All right. So what can we do maybe to help it? What do you think we can do? Can we've still got some toothpicks left and we've still got some marshmallows. All right, how's it falling? It's falling this way, isn't it?
Yeah.
All right, we could put,
Wait, I know actually something else.
what do you think? What do you think we can do?
I'm actually going to take off just like that. And then stick under this.
Oh, that's smart. But remember, we want to build the tallest tower possible.
They have to be together.
Okay. So that's what you're thinking?
Yep.
Okay.
All I need is 4 toothpicks, and then that's all the toothpicks I
Okay.
need for this.
Okay.
This one.
And you want these to stick together, right? Is that how you want to do it? Like that? Okay.
Are gonna need like all of the toothpicks.
That's okay. That's okay. But remember, you only have 30, and you still have all these marshmallows. Now, you don't have to use all of the materials, okay? But this is all you get, so you don't get any more.
I hope this will not fall.
You hope it won't fall. I know. Well, and you can't have anything holding it either, so, oh no.
It's not gonna break.
No? So what are you going to do to keep it from falling? You got to figure out something. Okay.
Well, I don't really know. I don't think we have enough.
Well, what if, we've got this here, we could take this apart, but what if, remember how the triangle was really
Wait,
stable?
hold on.
Okay.
Good.
Don't get this mixed up.
Stick this. And then there. And yay.
Mm-hmm.
Now, and then, yay.
Can I give you a tip? Okay. So remember how our triangle was really sturdy? Remember that? Okay. So what if we put some triangles in here by making, let's say, where it's not so sturdy, we could do a triangle like right there.
Ooh, right. Yeah, there's no more.
Well, we can use what we have. Let's see, where else is it not so sturdy?
Oh, it's also not that sturdy up here. Oh, over here.
Is it not sturdy up top or is it not sturdy at the bottom?
Bottom.
Got some problems here. All right.
Here's the building.
Okay, well, it seems a little bit better now that we've added some triangles. So the thing with the triangles are better at bearing the weight and the gravity of the upper layers than our squares or our parallelograms. That's a word. And so that's why the squares are more likely to fall than our triangles. And that's why sometimes engineers build in bracing, X-bracing, kind of like what we were starting to do here. But again, sometimes you have to really go back and figure out, just like Marshall did here, you did a great job engineering. You have to go back and figure out, okay, this isn't working. I need to go back and figure out what might work. So, how do you think we did? Did kind of okay. What do you think you might do differently next time?
Maybe I might just make it 2 blocks.
2 blocks?
Then it won't that really tip.
Would you build a triangle on top?
Maybe.
Maybe. Do you think you could do it better next time?
Yeah, probably.
Yeah. So these are the kinds of questions that you would want to ask about, what would you have done differently? Okay. Some strategies and some things that you might have changed as you were building. After all is said and done, what improvements could you possibly make to your design? Now, some extensions that you could do with this activity, there are lots of different things that you could do. Again, try this. You can try this challenge again and see if you can beat your record. Marshall, do you think you could build this bigger next time?
Yeah.
You think so?
Probably gonna do like 8.
You think you could do 8? I bet you could do taller next time. Yeah, especially thinking about, again, maybe we could do some of these triangle pieces. I bet
I'm
we could
thinking
do
maybe next time we might be like 80.
80. Well, we got to stick to the 25 and 30 because that's part of the challenge, right? So we could see if we could build it taller. We could challenge somebody else, right?
I know
Next
how
time.
I can do this.
Yeah.
At the beginning, I'm gonna keep starting actually to build the tower.
Yeah.
Like start actually building a cube, then another cube, then another cube with those.
Well, maybe.
And those.
Maybe. Okay.
Toothpicks.
Okay. Stay in your seat. Stay in your seat. I know you're really excited. Could your structure, here's another extension, could your structure like this survive a high gust windstorm or a hurricane? Or could it survive an earthquake? And so one of the things that you could do is get a fan with adjustable settings, or you could shake the table, don't actually shake the table, to see if it could survive those conditions. So that would be a really fun design challenge. And then you could investigate and research how engineers design buildings to withstand those kinds of conditions. And then again, you could use, this is another extension, using the same materials, could you build a strong enough structure to hold something like a deck of cards or even a book? Do you think your building is strong enough to hold up a book? No?
Well,
think you
unless it's a light book.
A light book? Do you think we'd have to build it differently in order to hold a book?
Yeah.
Probably. What do you think, what shape do you think would be strong enough to hold a book?
Probably a rectangle.
You think a rectangle? Any of these shapes? Do you think any of these shapes would be strong enough?
This.
Ooh, maybe that. That's a good idea. Well, maybe that's something we could try next time.
Yeah.
Right, next time we do this activity. So again, lots of things to think about. When you do this activity, lots of different directions that you can go. I hope you enjoyed your time with us here in my dining room, the Branch Museum extension. And I hope you got a lot out of it. Did you have fun? Yeah. We'll have to make sure that we wash our hands for at least 20 seconds because Marshall just picked his nose. Great job, buddy. Thank you all very much. I appreciate your time with us. I hope you have a great day.